Hello everyone, I am Ravindra Prasad and welcome to this session on pumps. In the video, centrifugal and reciprocating pumps are explained as a part of first year engineering subject Elements of Mechanical Engineering. A pump is a device used for converting the mechanical energy into fluid energy. A pump is a device that moves fluids like liquids or sometimes slurries by mechanical action. Pumps can be classified into three major groups according to the method they use to move the fluid: direct lift, displacement, and gravity pumps. Pumps operate by some mechanisms, typically reciprocating or rotary, and consume energy to perform mechanical work for moving the fluid. Hence, a pump is a power absorbing device unlike turbines which produce the power. Pumps operate via many energy sources, including manual operation, electricity, engines, or wind power. Comes in many sizes from microscopic for use in medical applications to large industrial pumps. Pumps are used for two main purposes. One is for the flow from low pressure region to high pressure region, and second is flow at a faster rate or at high velocity. Working principle of pump. In the figure shown, there is a sump from which the fluid is lifted and delivered to the delivery tank, and it is against the gravity. That means the fluid is going upward against a downward gravity, and for this upward acceleration is required, which must be more than the downward acceleration due to gravity value. In order to get this energy, the fluid must flow through a pump which is shown in the diagram at the center with a small circle. This pump is run by a motor or an engine. We can see two pipes named as suction pipe and delivery pipe are connected to the pump. Suction pipe help the fluid to flow from sump till the pump by suction, where the delivery pipe helps the fluid to flow from pump to the delivery tank. When the pump impeller or blade rotates, the fluid from the sump enters the pump due to suction created inside, where its pressure and velocity increases, which will help the fluid to move upward till the delivery tank. The total height to which the fluid is lifted is called as total head, which is the addition of suction and delivery head. In the second diagram, you can see another design where the lower tank is above the pump but it is below the delivery tank. In this design, the fluid flows from lower tank to the pump both by gravity and the suction created. Specifications of pump. First one is power consumption in horsepower. Example, half HP, full HP, 2 HP, etc. Pumps are selected based on the head requirement, that is the height to which the fluid must be lifted. As the height requirement increases, the power consumed by the pump also increases, and hence the power consumption is a very important parameter must be taken care of while purchasing a pump. If the selected pump is half HP, then it consumes power of 0.37 kilowatt. Second important specification is volumetric flow rate in millimeter cube per second. Volume flow rate or volumetric flow rate is also referred as the capacity. It is the volume of fluid that travels through the pump in a given time. It defines the rate at which the pump can push the fluid through the system. Third one is suction and discharge pressure. The unit is either bar or Newton per meter square or Pascal. Suction pressure is less than atmospheric pressure and responsible for the upward flow of fluid into the pump, whereas the delivery pressure is addition of fluid pressure and the suction pressure responsible for the upward flow of fluid till the delivery tank. Generally, the discharge pressure is greater than the suction pressure. Fourth specification is suction head, delivery head and total head. Unit is meters. The suction head, as the word says, is the height of pump from the sump. It is called as height but defined in bar, which is the unit of pressure. The delivery head, as the word says, is the height a pump can pump up water. The total height is the maximum pressure a pump can produce which is the sum of suction and discharge head. Fifth specification is efficiency. In this, many other subclassifications are there, like hydraulic efficiency, mechanical efficiency, volumetric efficiency, manometric efficiency, etc. Efficiency is the measurement of utilization of power consumed by the pump in lifting the water against gravity and the frictional resistance within the pump. Classification of pumps. Pumps are broadly classified into two types. One is turbomachines or rotodynamic pumps, in which rotational movement of the pump is converted into fluid energy. Second is positive displacement pumps, in which the fluid is compressed and the pressure and velocity of the fluid is increased when the fluid leaves the pumps. Subclassifications are given in the flow chart. Centrifugal pumps. Centrifugal pumps are used to transport fluids by the conversion of rotational kinetic energy to the hydrodynamic energy of the fluid flow. The rotational energy typically comes from an engine or electric motor which is attached to the pump. In these pumps, the centrifugal force is used for the fluid flow and in order to energize the fluid. Second, rotational energy converts into fluid energy. Hence, they are called as rotodynamic pumps. Common uses of centrifugal pump includes water, sewage, agriculture, petroleum, and petrochemical pumping. Centrifugal pumps are often chosen for their high flow rate capabilities. Construction of centrifugal pumps. The major parts of centrifugal pumps includes casing, impeller, suction side, and delivery side. Casing is a cover which houses impeller. Impeller is a rotating element connected to the motor shaft, and it is inside the casing. Volute casing is the most commonly used casing in case of centrifugal pumps. Impeller is a wheel or rotor which is provided with a series of backward curved blades or vanes. It is mounted on the shaft which is coupled to an external source of energy which imparts the liquid energy to the impeller, thereby making it to rotate. Impellers are divided into three types. First one is open impellers are used in small pumps to supply thick fluids like slurry, mud, oil, crude oils in refineries and power generation plants. Semi-closed impeller has an additional back wall, giving it more strength. These impellers can pass mixed solid-liquid mixtures at a cost of reduced efficiency. Enclosed impellers generally used in large pumps and clear water applications. The construction of closed impellers includes additional back and front walls on both the sides of vanes that enhances its strength. This also reduces the thrust load on the shaft, increasing the bearing life and reliability and reducing the shafting cost. Suction pipe is connected with the inlet of the impeller and the other end is dipped into the sump of water. At the water end, it consists of footwall and strainer. The footwall is a one-way wall that opens only in the upward direction. Strainer is used to filter the unwanted particles present in the water to prevent the centrifugal pump from blockage. Delivery pipe is a pipe which is connected its lower end to the outlet of the pump, and it delivers the liquid to the required height. Near the outlet of the pump on the delivery pipe, a valve is provided which controls the flow from the pump into the delivery pipe. Working of centrifugal pump. The first step of operation of a centrifugal pump is priming. Priming is the operation in which suction pipe and the casing of the pump filled with liquid which is to be pumped so that all the air from the pump is driven out and no air is left. The necessity of priming of a centrifugal pump is due to the fact that the pressure generated at the centrifugal pump impeller is directly proportional to the density of the fluid that is in contact with it. If the air is not removed, as it has low density as compared to water, the water will not flow upward in the suction pipe. Electric motor is started in order to rotate the impeller. The suction created thus lifts the water into the pump casing where due to the centrifugal action of the impeller, the fluid is thrown away from the eye of the impeller. This centrifugal action increases the velocity and pressure as well. And with this high energy, the fluid can able to flow upward into the delivery tank. Cavitation in pumps. Cavitation is a process in pumps where the pressure of the fluid falls below the vapor pressure. Vapor pressure is the pressure at which the liquid starts to boil. So at this stage, when the pressure falls below the vapor pressure, the water boils off and that results in formation of bubbles. These bubbles are then acted upon by high pressure fluid surrounding it in the impeller, due to which the bubble implodes. Implodes create shock wave that hits the impeller and other parts of the pump casing and creates pump vibration, mechanical damage, and possibly leading to the complete failure of the pump at some stage. Reciprocating pumps. A reciprocating pump is a class of positive displacement pumps. It is often used where a relatively small quantity of liquid is to be handled and where delivery pressure is quite large. In reciprocating pumps, the chamber that traps the liquid is a stationary cylinder that contains a piston or plunger. In these pumps, the fluid is compressed inside the cylinder in order to increase the pressure using the cylinder piston arrangement. And also, rotation of the crank is converted into reciprocating motion of the piston, then that will be converted into pressure energy of the fluid. Hence, it is called as positive displacement machine. Components of reciprocating pumps are as follows. Piston or plunger. A piston or a plunger is a cylindrical disc of small thickness, reciprocates in a closely fitted cylinder. Crank and connecting rod mechanism operated by a power source. Power source gives rotary motion to the crank. With the help of connecting rod, rotation translates into reciprocating motion of the piston. Suction pipe remains deep in the liquid and other end of this suction pipe is connected to the inlet portion of the cylinder, whereas delivery pipe is attached with the delivery part of the pump and another end is at discharge point. Suction and delivery valves are provided at the suction end and delivery end respectively. These valves are non-return valves, that means they don't allow the backflow of fluid into the sump. The working principle of reciprocating pump is as follows. Initially, both the suction and delivery valves will be in closed position. When the power source, that is the motor or engine, is connected to the crank will start rotating and connecting rod also displays along with the crank. The piston connected to the connecting rod will move in linear direction. If the crank pulls the piston, vacuum creates inside the cylinder. This vacuum opens the inlet valve or suction valve and draws the water into the cylinder. When the crank pushes the piston moves forward and closes the suction valve and apply the pressure on the fluid which is present inside the chamber. When the piston reaches its extreme left position, the whole liquid present in the cylinder is completely pressurized and this pressure will open the delivery valve and the fluid rushes out with very high pressure. When the fluid with very high pressure leaves the cylinder, the velocity increases and because of this the fluid moves at very high velocity or speed into the next delivery tank. Thank you for watching.